Hello, everyone. As Sarah mentioned, my name is Lucas Meredith. I'm from here in Telluride and go to Telluride High School. And I actually did 3 internships during the course of my summer. I did an API data transfer internship, an internship with the neuromorphs, and computational chemistry at ASU. So, yeah. As mentioned, I did an internship doing an API data transfer, and it was only 1 week, and it was here in Telluride, and actually had the luxury of being able to work from home primarily during this internship. And essentially, I was helping the director of research and science, Evan Iverson at Telluride Institute, transfer data from one website to another website using an API. And essentially, the data that was coming from one website was raw data from a data stream, and I had to format that data using an API to transfer it to this other website to make it look graphically interesting and like visibly pleasing. So a lot of the data that was coming in from a Adafruit Featherboard with a bunch of like atmospheric detection peripherals on it. So this Featherboard had like temperature gauges on it, humidity detectors on it, and it would all compile this data and it would send this data via something called LoRaWAN, and you can see this right here. And the thing with LoRaWAN, it's different from your typical radio comms because it can go typically longer distances and uses a lot less power as well as about an average bandwidth. And so from this Featherboard, LoRaWAN signals were transmitted to a gateway. This gateway put it on a server, and the server was then used, then transmitted that data to this dashboard, which you can see up here, which has all this data graphically laid out pretty nicely using the API. I coded the API in Python, and it was a really fun experience. I learned a lot, and it was actually one of the first times I've used an API and coded with an API before, so it was great. My second internship was working with the neuromorphs, which was the neuromorphic cognition engineering workshop. It was 3 weeks, and it was also here in Telluride. It was kind of weird because this workshop was set up in a high school, so let me give some context. A bunch of these really smart people from all over the world, internationally, from like France, maybe England, all over the world, came together from even prestigious schools like Stanford or Columbia, and they all came together for the hope to innovate about like neuromorphic design and neuromorphic ideas. And during the course of this workshop, there were plenty of lectures. Like this one was like some sort of Monte Carlo probability lecture, and a lot of these lectures went over my head, and I realized how stupid I am because these people were really smart, and I realized that yeah, I don't know anything. So there were 4 key groups during this workshop. There was an auditory group, there was a neuromorphic circuits group, there was like a brain sort of group, and then there was an AI group, and also integrations and space group. So yeah. I had to decide which group I wanted to join, and within each group there were subgroups, and at the end of the workshop you had to present on what innovations you made, what project you did, and I decided to join the auditory group, and as you can see here, I'm rigged up with an EEG on my head. It essentially puts a bunch of these metal nodes into your cranium, which is pressing into it. It was a cool experience, but it hurt like a lot. And the game that I was developing for the presentation we were going to do at the end to show our progress that we made was a mountain biking game, and essentially I made it in Python using Pygame, and you keep your cursor that's connected to a bike on a track. If you deviate off the track, then you essentially get an error, and we were trying to measure with the EEG the sensory brain activity from it. So we were trying to isolate the sensory brain activity from the motor brain activity that you were playing the game with. And in an ideal world, you'd be able to decode the sensory brain activity into maybe using it for another computer, which would be able to play the game before you actually moved your hand to play it, because you're sensing before you actually move the mouse to keep the mountain bike on the track. We didn't get that far, but we got like a rough model of it, which is pretty cool. And yeah, there was a lot of fun stuff during this workshop, and a lot of smart people, and yeah, it was great. Fun things I didn't tell you. I actually went into the 4th of July parade, and I marched with the neuromorphs, which was really cool. And I also went tubing. I don't suggest tubing, just because my personal experience, it was really cold. But yeah, I did a lot of fun stuff in Telluride as well. My last internship was computational chemistry at ASU, and it was for 2 weeks. And as Sarah mentioned, Matthias Hayden, the assistant professor that set me up with this amazing internship, had to jump through a lot of legal issues with the ASU, and I'm so grateful for him for doing that. And I worked with his team doing computational chemistry, which is just basically simulating maybe atomic reactions or atomic collisions or chemical reactions on a computer, and it simulates these reactions or interactions. And I did a lot of bash scripting during this internship, which I haven't used bash a lot, but it's essentially like a coding language, you could think of it as. And that was pretty fun. I had a lot of these things called nerd outs, which was essentially, they had a bunch of these really complicated equations on the board, and they did a great job explaining them to me, but they're like, God, they were really complicated. I mean, but they were awesome, and they did a great job, so yeah. I was able to work on the supercomputer at ASU. I didn't actually take this photo, but it looks like I did because of the resolution on it. But yeah, I worked on a supercomputer for like high computational rate, like simulations. I made a 1D oscillator, only using physics principles, so we like really had my brain working for that. And I got a beginner introduction to the library that they use, which is called GROMAX, to actually create these amazing 3D animations in like an OpenGL software. So yeah, thank you so much, Matthias, and the rest of the people I worked with. Not yet. What I did outside of ASU, I made some water sims, collision sims, explored the campus, and I played a lot of Halo with my roommate, which was amazing. Future Pinterns, anything that you have an interest in, there's most likely an internship out there for you. You get to push the limits of what you really know. You can meet plenty of people and connect with them. I got to meet many great people, and it makes you really think about what you're going to do later in life, and gives you exposure to fields, or in my case, 3 fields, but what I'm very grateful for. And yeah, so thank you to all these amazing people for making awesomeness occur. So thanks.